The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI Web Sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
Okay, so we'll keep things going, and we'll bring Attila. So there you go. Just
Attila.
Okay.
Okay. Good afternoon, everyone. My name is Attila Beres. I'm one of the regional staff members of CRSI. I joined CRSI about 3 years ago, and I'm delighted to see actually Amy Trigestad with Dr. Mike Mota and Amy. We used to work together as the regional staff of PCA, and I do see a number of familiar faces in the audience, so this is a little deja vu here. Before we segue into the presentation, let me know that CRSI is available for a variety of activities that may help you, practicing engineers, code officials, universities. We do a whole bunch of seminars that you may find useful, embellishing your technical knowledge. At any rate, CRSI and Voided-Slabs. Okay, in a few years ago, my distinguished colleague Mike Mota approached us that he stumbled on an interesting rebirth of a technology that really has been out there for a number of years. And with our colleagues, we looked at some of these new inventions, and we saw that, hey, there is an opportunity out there to build with concrete in an innovative way that some of you may term as a game changer. As you know, concrete systems have had tremendous advantages in the marketplace for many good reasons. However, there are certain handicaps we admittedly do have, and that handicap is mostly associated with the weight of concrete systems. Concrete floors, in particular, has been in use with great success because they provide really a robust, sturdy, durable system that's capable to serve purposes really well. However, we have been somewhat limited in terms of our ability to span great lengths and address issues where the live load is relatively high. Now enter voided slabs, and as Mike pointed out, this is really not something totally new under the sun. Our intent with lending support to the few operations who are ushering in this new technology, new and old, I should say, in apostrophes. This was basically to provide a guidance to design professionals as well as contractors to reintroduce this system that has seen this rebirth. We have started out at CRSI with a number of publications that were mostly geared towards contractors. These were articles placed in trade publications, and also Mike did put together some information in terms of sample specification, and we are heading towards this guideline that will include suggestions for general notes, typical details, whatnot. In the previous presentation, you have seen a cross-section of a variety of systems that have been used since the flood. And I'm using the flood again, because Mike only traced back to 100 years, but truly about 2,000 years ago when the Pantheon in Rome was built, they have used the concept of getting rid of the fluff, the extra concrete. Basically, they built a coffer dome system that was capable to span about 140 feet. 140 feet or 40 meters for those of you who are from non-SI countries. This has been an incredible achievement, and I see my boss Bob Research sitting at the back row. Bob, would you please walk out the door for just a moment, because I wanted to mention that in Rome they have achieved that without a single piece of reinforcing steel. Now, today, there are steel companies who are chasing the same dream, getting rid of concrete. And it sounds a little funny that we are at the ACI convention and we are talking about reducing the amount of concrete. Truly, these are situations where actually by eliminating some of the extraneous amount of concrete is actually buying us opportunity to quote-unquote sell concrete. There are opportunities to introduce reinforced concrete systems in places where those systems have not been competitive. And there are a couple of photos here just to give you a glimpse of what's out there today. Obviously, people have been using the joist systems that Mike had mentioned, the Voided-Slab system with the whole core planks. Those systems has been really extensively used around the country. Some parts of the country favor certain systems, other parts favor others. Nevertheless, we can take these systems to a higher level, if you wish, with some of the approaches that have been taken in the last few years. If you go walk through these photos on the upper left, you would see a system using glorified styrofoam, polystyrene, as an insert. Mike has shown this as part of the filigree system. Nevertheless, practicing engineers would be quick to point out that we have used polystyrene in slab applications where there has been, for instance, a step in a floor systems to alleviate the weight issues. On the top center, two figures show kind of a crate type of void. This is very interesting. We stumbled on this not in this country but in Europe. Basically what you see here is something like a box that people use to carry certain things. The beauty of these systems is that you are able to kind of stack these boxes into each other because they are open on one side, thereby reduce the amount of space that you need to transport. On the right-hand side at the upper line, you see cardboard, basically glorified cardboard that's a little waxy, if you wish, that can be used to generate voids. We have not seen too much of these being used around the world. I have got these pictures from Australia. Similarly, you would have the tube system around. Again, this has been tried out at a relatively large-scale project in Irvine, Orange County, about 30 years ago. However, we have not seen it in building applications. We have seen a couple of uses in bridge structures. Now, the lower three figures do relate actually what we are really focusing on today, because that appears to be in vogue, if you wish. The two systems and our two speakers afterwards are basically the purveyors of two of the systems. These are essentially plastic balls, very thin-shelled, hard plastic balls that are going to displace concrete and they are basically void formers, if you wish. Now, there are endless opportunities how you can generate these voids, and the third option is a company's option that is out of Latin America. They have introduced, for instance, all kinds of dimples on their bubbles that help to locate the rebar and serve as a kind of a spacer in between. And I'm sure the two gentlemen from here would be quick to point out that they are pretty much capable to do the same or something similar tricks to achieve that. Now, with our work on putting together a guideline, we had the good fortune to work together with some of these companies, and I would like to give credit to all these people. CoBX and Bubble Deck has been the two companies who are really present in the US, and we have Mike Rusillo here, also Dan Windorsky, who is the engineer for Grave, closely affiliated with Bubble Deck, who are going to pick up this presentation after me. So feel free, if you have any serious questions, to relay those to these two gentlemen, because they are the ones who know what they are doing. Okay, also wanted to mention that we got some inputs from actual contractors who did work with the systems. And just to give you an idea of how significant buildings are being built with these, truly there has been very, very big high-rises, 40-story plus, that have been built with the systems, and very prominent airport structures and others. Nevertheless, the system seems to be applicable to a variety of uses, and we can go through all the different type of buildings that have been constructed, literally from office to residential to commercial spaces, and whatever you name it, has a wide range of applicability. The intent with our guideline is going to address anything and everything that you need to ask about these systems as a designer and contractor. So it will start out with an introduction and provide a somewhat similar historical overview that Mike have given you. We will go through construction issues, design regulations. We will provide some design tools, and the last few slides of this presentation, I'm going to give you a little flavor of what CRSI has launched very recently, and we are going to also give you a couple of case studies, feature some actual projects. Now, looking at this outline, quickly, some people would say, what on earth are we trying to address constructability issues in terms of the design guideline? Truly, because one way or the other, there is nothing really new about this system, sort of from design perspective. We are trying to do something that has been accomplished with different means. So truly, the means and methods, the construction means and methods are making the difference. Another important issue to mention is the general contractors and subcontractors are always viewing structural systems that are relatively new with some sort of skepticism, and we would like to alleviate those concerns, because indeed, anytime a new system is being introduced, people perceive it that, am I taking a risk? So they are going to pad their numbers to assume that risk. And it's not only the trades that are directly working with the items, but whenever there is a building constructed, the electrical contractor, the plumber, all the other trades would see the new systems with some degree of skepticism, because they don't want to eat a potential extra because of complexity associated with the unknown. So these constructability issues are truly essential to understand the design, and For those of you engineers out there, here is an opportunity to basically to promote a new system and distinguish yourself as providing something different. Many owners, our role as structural engineers, for those of you as structural engineers in the audience, is basically to be the advocate and advisor to the client. So here is an opportunity to tell people, to evangelize. Now, in order to understand the building methodology, as Mike has pointed out, one of the critical issues is securing the void formers against buoyancy, and how we sequence the rebar placement, the placement of the void formers, and the concrete. Basically, with these new systems, what we see out there in the US is basically a two-stage operation. The projects that have been constructed so far has been either an two-stage cast-in-place process that COBX has featured on the Miami Art Museum project, and a precast, cast-in-place hybrid system that the bubble deck projects have been promoting. Nevertheless, I believe both of these companies and the others are capable also to provide these systems. So you, as I understand correctly, you guys are not necessarily married to one type of placement method. It just happens that on the current projects that's what took place. I should also mention that the third company that I have featured one of the photos, Prinova out of Argentina, they did patent. Actually, the patent is pending in the US, I believe, but they patented the system elsewhere, where they are providing a attachment of the bubbles or balls, if you will, the void formers, that are going to anchor those to the formwork, and instead of two placements of concrete, they are operating on a one concrete placement situation. Now, obviously, the thoughts about economy on this, you would get different opinions from different people you ask. And here we have an opportunity to ask the two speakers whether they have seen it as a handicap or whether that has been mentioned as a detriment to the process. As I understand, it was not. And from most practicing engineers, you would realize that if you have a reasonable size of floor plate and you start even with the two-stage cast-in-place process, you can start out placing the concrete in one corner, and by the time you basically go around placing the concrete on the floor plate, the concrete would set in short time frame. So within the same day, you can place the concrete in the second lift of operation. As far as construction methods, when I was a practicing engineer in my previous life, I have to admit that I was just simply not cognizant about the significance of cost, and in the context of concrete, the significance of cost associated with shoring and forming. It is quite astonishing sometimes that forming costs can rise to such high percentage as 40+% of any concrete operation if you are not devising it properly. Same way, placement of rebar and placement of void formers can be a significant cost compared to the amount of concrete and rebar that you are using. So technological construction means and methods issues are paramount. So the constructability issues that we are going to try to address in the context of a guideline is consolidation of concrete. All these concerns, I'm going to have only time today here just to very quickly go through the set of issues, and you may ask questions to the next speaker, what has been their take on any of these, and I'm sure as part of your presentation, you are going to make reflections on some of these. So whether there has been a concern with the interface of the two concrete lifts, whether the first one is a precast, as in case of the bubble bag projects, or whether it was a cast in place. It is basically a very, very large surface that we are trying to interconnect. And I think that kind of works to the benefit of concrete because of the sheer surface area that we are trying to shear. Resiliency of the void formers. This is an issue that pops up very often, whether those are getting damaged at the construction site. Is this a realistic issue? Do we have to reposition certain void formers? What is the learning experience in terms of time to completion? Time is money, right? So detailing concerns. How do we deal with post-installed anchors? That's probably one of the issues that I'm being asked the most often when we are giving presentation on this subject. How do we deal with anchors that are placed into the voided slab system after the building is constructed? Can we drill intentionally into the void formers? It has been pointed out to me that at certain situations that could be actually an advantage, that here is a location where you can easily lead through a duct pipe, or even I have seen a picture where a light fixture was placed at the location where the void former is provided. There are obviously engineering issues and constructing issues with transition between the voided areas and the solid zones. Is there an interconnectivity issue in between the precast components? With all precast systems, people have had this overarching concern that it's a fantastic way of constructing in many regards, but how do we stitch together these systems? How do we accommodate any sort of electrical, mechanical, let alone post-tensioning conduits on these slab systems? There are obviously administrative implications that we engineers don't like to think about. Who is responsible for the placement and shop drawings in a situation where there is this convoluted set of players in the system now with these added key components? Any ramifications for specifications? What are the special issues associated with inspection? Whether is it code compliant? And in terms of code compliance, obviously we are talking about ACI 318 as well as some other building code compliance issues such as fire rating. And then there is the non-code compliance issues as well, because people have in the last few years all kinds of concerns that are not necessarily codified per se, but sustainability, LEED regulations. How do we meet with those? And I'm happy to report that some of these projects have received very, or at least aspiring for very high LEED ratings. Are there any pros and cons as far as the vibration resistance of these systems? Are they going to help us with sound insulation or thermal properties as such? Now, for the sake of those of you who are hardcore analysts and designers in the audience, let me just very briefly tell you what are the steps that we need to go through when you are designing a system like this. We are basically defining a computational model and parameters. We try to establish all kinds of adjustment factors. We are not necessarily working with a radically different system that you have seen before. We have a few adjustment factors for the weight, the stiffness, and shear strengths that are, for the most part, tend to be just single numbers that we use to facilitate the calculations, to do it kind of the old-fashioned way. Then very often people use existing computational tools, so they incorporate the slab weight by default based on the thickness of the slab being used. we can come up with negative load patterns. We perform an initial analysis as the first estimate, and then the key issue tends to be dealing with the shear. Shear reduction is very, very substantial, as you may imagine, in systems where we are putting these gigantic voids in the slab. We are talking about magnitude of reduction 40 to 50%. So that's the one that tends to drive the system. In old-fashioned solid slab design, it tended to be the deflection concerns. Now, because of the advent of reducing the weight and sometimes making the slab just a tiny bit thicker, deflection concerns tend to go away, and shear is taking place of the major concern. Now, after a few iterations, you figure out where are the locations where you place the void formers and other locations where you leave out, where you need all the shear capacity of the full solid cross section, and that's the point where you perform the flexural design. So in a nutshell, that's more or less the design process. And as I said, okay, I have the red light blinking in the corner, so okay, these are the parameters that are being used in the structural analysis and design, as I walked you through that. Here are two examples of weight reduction. Just very quickly show you that an 10-inch slab, if you place in the typical void former, just ballpark what these two companies are using, you end up basically a 30% weight reduction, which basically puts reinforced concrete in par with structural steel systems. So that's a major game changer, and that stays for longer spans and heavier loads. Basically, you get a similar weight benefit as such. Now, there are other engineering considerations, the seismic shear diaphragm issues that we need to address, and deflections and other issues. I want to get, before our distinguished chairman is going to cut the mic. Mike is cutting the mic, right? Okay, to this slide. This is my last pitch for CRSI. We have introduced a very interesting design tool that many of you, not only the designers, but also contractors may find it useful. This is called RC Concept. And this is for preliminary design. We have a capability to address, in rudimentary means, approximate methods, couple of floor systems. These are the traditional flat plate joist systems, and now we have incorporated voided slab systems where you are basically putting in some of the basic data, including the geometry, the load, the materials, as you may imagine. And you have basically a typical rectilinear layout where you can put in a couple of spans. Obviously, this is not going to give you a full-blown detailed design. This is not a full-blown finite element package. We are not competing with some of the big guys of the software industry, but our goal is to give you some basic numbers, kind of back-of-the-envelope style, if you wish. Now, we are able to accomplish that, and even you can get some dark screens and error messages indicating, flagging you that, hey, you are doing something totally wrong if you are not complying with the initial design with some of the dimensional limitations that are going to be set. Nevertheless, the results are fairly useful, and for those of you who have access data to finances in terms of construction costs, you can also plug in a couple of figures for that. And it gives you some estimates. Our goal was to provide you also estimates, not only in terms of the amount of rebar you need, but also dollar figures where you could see that for a given floor plate, given span, whether it is the voided slab system or some other systems that might be the best to use. Now, let me transition the
Hold on,
Sandra,
before
you
you do
want to-
that, Attila, I just
Okay.
want to add to Attila's comments that concept is available at the CRSI.org website. It's free to everyone. But in addition to the voided slabs, we also feature other types of slab systems, a flat plate, a flat slab, a one-way joist system. So all kinds of, the 6 or 7 different common systems are available that you can use from a preliminary analysis perspective. The other thing I'd like to just expand on what Attila said, with the voided slab, especially on the West Coast, by reducing the dead load, you're reducing the seismic demand on the structure. So that becomes a very attractive proposition building on the West Coast, where obviously seismicity is an issue. Conversely, on the East Coast, it's the long spans. It's the office buildings that are traditionally structural steel that we're going after with the long span concept with the voided slab. So, Attila, thank you very much. We're going to move on now. Is there any questions for Attila? I think the other thing you didn't mention was there was a slight stiffness modification, so I don't know if maybe Mike or Dan can talk about the modification to the stiffness. But thank you, Attila.
Yeah,
very
thank
much.
you, Mike. I think it's